Alright guys, welcome back to the 5th virtual day in this whole big mess. Your homework is going to be 2 parts. Part 1 is simply you guys watching this video and taking notes over the problems like we would be in class. Part 2 of the homework I'm going to save to the end of the video. Alright, so you got to wait to the end of the video before I tell you what part 2 is. Probability starts getting a little bit more complicated when we start talking about or events and events. So what I mean by that is what's the probability of something happening or something else, or the probability of this thing and this thing happening at the same time. So right now this week we're only going to worry about or events. All right. Some of them are really easy. Some of them are a little bit more difficult. I'm not gonna say that they're the most difficult thing ever, but the problem is you have to figure out whether or not or events are mutually exclusive or not. Mutually exclusive means 2 events cannot happen at the same time. All right, sometimes they're called disjointed events. If something is not mutually exclusive, sometimes that's called mutually inclusive. It means they can happen at the same time. So I have a couple of examples here. Let's say we're rolling a 6-sided die. If we wanted to find the probability of rolling a 3 or a 5, well, you can't do that at the same time. You can't roll one time and it lands on a 3 and a 5. That's impossible. So that's called mutually exclusive. If we rolled that same 6-sided die and we wanted to know what's the probability of rolling a 3 or a prime number, well, the prime numbers on a 6-sided die are 2, 3, and 5. So it is possible to roll a 3 and a prime number at the same time. Rolling a 3. 3 is prime. So those are not mutually exclusive. And you find the probability of these 2 things a little bit different. If they are mutually exclusive, you simply take the probability of the first one and add it to the probability of the second one. If they are not mutually exclusive, again, that can be called mutually inclusive, you add the 2 probabilities just like you did up here, but you have a third step. You have to subtract the probability that they happen at the same time. Okay, that might seem really confusing right now. Sorry, my voice cracked there. I sound like the 14-year-old, not you guys. So the hardest part of this is figuring out whether they're mutually exclusive or not, and then remembering which formula to use. So I plan on going through quite a few examples. We'll start with our spin wheel that we seem to be using quite a bit. The first one says, what's the probability of a 2 or a 5? Well, if you look at this spin wheel, it is impossible to land on both the 2 and the 5 at the same time. So they are mutually exclusive, which means we just take the probability of spinning a 2 plus the probability of spinning a 5, and we're going to add those 2 together. So the probability that we land on a 2 is 1 out of 8, so that's 1/8 plus the probability of landing on a 5 is also 1/8. Add those together, we get 2/8, which reduces to 1/4. So the probability of landing on a 2 or a 5 is 1/4. All right, let's look at the second example. The probability of odd or an 8. Now, 8 is not an odd number, so these cannot happen at the same time. So once again, we have an example where they are mutually exclusive. So I simply take the probability of the first one and add it to the probability of the second one. The probability that it's odd is 1, 2, 3, 4 out of 8. The probability that it's an 8 is just 1 out of 8. Add and you get 5/8. So the probability that we land on that spinner, or I'm sorry, that the spinner lands on an odd number or an 8 is 5 out of 8. All right, so far, not that complicated. This one is where it gets maybe a little bit weird. The probability of even or prime. So remember, the first thing you have to ask yourself is, can this happen at the same time or not? If not, it's mutually exclusive, like these two were. If they can happen at the same time, it is not mutually exclusive. Well, if we start looking at prime numbers, 7's prime, 5's prime, 3's prime, and 2 is prime. Not only is 2 prime, it is even. So this can happen at the same time. So we need to take the probability that it's even plus the probability that it's prime minus the probability that it's even and prime. I had to abbreviate there, I was running out of space. I just used E and P for even and prime. So the probability that it's even, well, that's 1, 2, 3, 4. That's 4 out of 8. The probability that it's prime, 1, 2, 3, 4. That's also 4 out of 8. Minus the probability that it's both even and prime. Well, that only happens once. That's 1 out of 8. 4 plus 4 is 8, minus 1, 7 out of 8. So, if you spin this 7 out of 8 times, it'll either land on an even number or a prime number. Our only exception is 1, because it's odd and it's not prime. That's the only way you don't win, if you want to think of it that way. All right, now, why do we have to do this? Why do we have to do this thing where we have to subtract this where it's both? So I'm going to attempt to explain that. If I go through and I put a check mark on every, sorry, I got something in my throat. Every even number, I'll have a check mark there, 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 and there. Now, if I go back through and put a check mark on every prime number, well, 2 is prime, 3 is prime, 5 is prime, and 7 is prime. So notice, I have 8 check marks up here. But I only have 1, 2, 3, 4, 5, 6, 7 wedges that are checked. This one is double checked. Again, 1 is double checked. Well, look how many we subtracted. 1 out of 8. You have to subtract where it happens at the same time, because if you don't, you count it twice. Right? If I counted check marks, I have 8 check marks. But if I count wedges, I have 7. So you go back and subtract where it happens at the same time, because in essence, you're counting it twice. So you want to subtract where you counted it twice to get the right amount of desired outcomes there. All right. Let me erase. We got another spin wheel here. Hey, Steph. Steph. Trying to get my wife to get me water. She's not even down here. All right. The probability that it's yellow or odd. Again, ask yourself if it can happen at the same time. And this one can, so it is not mutually exclusive. Right here, we have a yellow wedge and an odd number. So we're going to take the probability that it's yellow, I'm going to be lazy and just put Y, plus the probability that it's odd, minus the probability that it's both yellow and odd. The probability that it's yellow is 1, 2. So that's 2 out of 8. The probability that it's odd, 1, 2, 3, 4, that's 4 out of 8. Minus the probability that it's both, well, that's only 1 out of 8. So 2 and 4 make 6, minus 1 is 5. 5 out of 8. Now we want the probability that it's blue, or, remember that little apostrophe there means it's the complement, so that's blue or not prime. Well, we have 2 blue wedges that are blue and not prime. 4 is not prime and 6 is not prime. So again, this one is not mutually exclusive. So we're going to have to subtract where they happen at the same time. So probability of blue plus the probability that it is not prime minus the probability that it's blue and not prime. Blue wedges, I have 3 of them. So the probability that we land on blue is 3 out of 8. The probability that it's not prime, 1 is not prime, 4 is not prime, 6 is not prime, and 8 is not prime. So that is 4 out of 8, minus the probability that it's both blue and not prime. Well, we already said this once. 4 is not prime and it's blue. 6 is not prime and it's blue. So that's minus 2 out of 8. 3 plus 4 is 7, minus 2 is 5. 5 out of 8. All right, now we want the probability of red or even. Well, the only red wedge up there has a 7. So those cannot happen at the same time. Therefore, they are called mutually exclusive, which means we just take the probability of the 2 and add them together. So the probability of red plus the probability of even. Probability of red is 1 out of 8. The probability of even is 1, 2, 3, 4 out of 8. So again, we get the probability of 5/8. We got it all 3 times on that one, which is kind of weird. All right, I think that's the last slide. Let me peek here. Yeah. So I know that wasn't a whole lot of examples, but your other homework is actually not anything to do with probability. It's not anything to do with math. Okay? Although I do want to encourage you to do something. I'm recording this at, what time is it? At 8 o'clock. And I have about 146 of those forms filled out. I would like to get 400 or more. So if you get super bored tomorrow, you don't have to, as long as you've already done it 3 times, but it'd be awesome if you could fill out that form. I'd like to get those numbers way up. Okay. Now, back to the second part of the homework. It's 3 weeks of this at this point, I think. Maybe going on our 4th week. I've lost track, to be honest. Many of you are fortunate enough to still have grandparents in your life. Unfortunately, I'm not one of those. But here's what I want you to do. Reach out to a grandparent. If you don't have a grandparent in your life anymore, unfortunately, reach out to somebody, some loved one that you haven't got to see over these last 3 weeks. And I know this is weird for your generation, but your phone actually makes calls. Right? It's way more personal. Pick up the phone, call that person, let them know you miss them, let them know you love them. That's the second part of your homework. That's going to go a long way for that person that receives that phone call. Right? So, second part of your homework is doing something for someone else. Let someone know in your life that you haven't seen in a long time. Let them know. Ask them how they're doing. Like I said, let them know you miss them. Let them know you love them. And that'll be the second part of your homework. Unfortunately, Thursday's homework is going to be back to math. It'll be a homework worksheet over this. Hopefully you took notes. Hopefully you make that phone call. And hopefully you fill out some more of those Google Forms for me. I want to get those trials way up there so we can see if that law of large numbers gets even closer to those 25, 25, 25, 25. All right, guys, miss you a lot. I hope everything's going okay. If if you guys are needing something at home, whether that would be food or whatever, reach out. Reach out to me. Reach out to Student Services. See you guys.